Hello, my dear students, and welcome back. Hey, I know, exams are just around the corner, and this chapter, Permutations and Combinations, it can feel a little bit scary, right? But don't you worry. Just stick with me. I promise, by the end of this, you'll feel like you have a new superpower for solving these problems. We are going to make it super simple. Let's dive in.
So let's start with something you do every single day, choosing what to wear. Just imagine, you're looking at your clothes, you have a few pants, a few shirts. How many different outfits can you actually make? You see, this isn't just some boring math from a textbook. It's everywhere in your life. And this simple, everyday question, it's the key to unlocking this whole chapter.
Okay, before we even whisper the words permutation or combination, we need to master one thing. I call it the golden rule of counting. Your book might call it the fundamental principle of counting, but trust me, it's the golden rule because, well, it's the foundation of everything we're about to do. If you get this, the rest of the chapter is a piece of cake.
Let's take this classic example. Everyone, meet Mohan. He's got 3 pants and 2 shirts. Now think about it. If he picks the first pair of pants, how many shirt options does he have? 2, right? Good. What if he picks the second pair of pants? Again, he has 2 shirt options. And for the third pair, you guessed it, 2 more options.
And that brings us to our golden rule. You just multiply the number of choices you have for each step. So, 3 choices for pants, and for each of those choices, we have 2 choices for shirts. So what do? Simple. 3 multiplied by 2 gives us 6 possible outfits. Easy, right? And hey, if Mohan had, say, 4 different caps, we just multiply by 4 again.
All right, now that we've got our golden rule in our pocket, let's talk about the first big idea, permutations. I want you to think of permutations as the arrangement game. In this game, the most important thing, the absolute hero of the story, is the order in which you place things. The textbook definition is actually perfect and simple. A permutation is an arrangement. That's it. That is the one magic word you need to remember. I want you to repeat after me. Permutation, matlab arrangement. Anytime you see the word arrange in a problem, a little light bulb should go off in your head. So, the main idea, the big takeaway is this. In permutations, order matters. It matters a lot. Think about your phone password. If it's 1234, will 4321 work? No way. Or think about a running race. Coming first, second, and third is totally different from coming third, second, and first, right? The order is everything.
Now, to make our lives easier, mathematicians gave us a super cool tool. It's called the factorial, and it's just this little exclamation mark. It's a shortcut. It simply means you multiply a number by every whole number smaller than it, all the way down to 1. So 4 factorial is just 4 times 3 times 2 times 1, which is 24. So useful.
And here's the big formula. Don't let it scare you. It's actually quite simple. N is just the total number of things you have to choose from, and R is how many you're actually picking and arranging. This formula is just a quick way to figure out how many ways you can arrange R things from a bigger group of N things.
Okay, you're doing great. Let's move on to our second big concept, combinations. Now, if permutation was the arrangement game, then combination is the selection game. The name of this game is just choosing stuff. The order, totally irrelevant. It just doesn't matter.
And just like before, the definition is our key. A combination is a selection. That's our new magic word. Say it with me. Combination matlab selection. So if a question asks you to choose a team or select some items, and the order doesn't matter, you know you're dealing with a combination.
The most important thing here is order does not matter. Think about making a fruit salad. If you put in apples and then bananas, is it different from putting in bananas and then apples? Of course not. It's the same salad. Or, for you cricket fans, if we select Rohit and Virat for the team, is that different from selecting Virat and Rohit? No, it's the same team.
And here is the formula for combinations. Now look closely. It looks a lot like the permutation formula, doesn't it? But there's an extra little part in the bottom. We're also dividing by R factorial. And why do we do that? Well, it's to get rid of all the different arrangements of the same group. We don't care about the order, so we divide them out. All right, now for the main event, the final showdown. The biggest, most important skill you need for your exam is figuring out, should I use permutation or combination? Getting this right is the secret to scoring full marks.
So let's put them head to head. Permutation, the key word is arrangement. Order matters. Think of your phone lock. Combination, the key word is selection. Order does not matter. Think of choosing toppings for your pizza. That's it. This one slide is your key to winning this battle.
Okay, enough theory, enough talk. The best way to learn is by doing, right? So it's time to use our new superpowers and crack a real exam question. Are you ready? Let's do this.
Okay, have a look at this question. It's a classic. In how many ways can the letters of the word daughter be arranged so that all vowels occur together? Now, pause for a second and think. What's the key word here? It's right there in the question, arranged. So is this a permutation or combination problem? It's a permutation problem. See? Easy.
All right, let's solve it. Step 1, find the vowels. In daughter, they are A, U, E. Simple. Step 2, the rule is they have to stick together. So let's imagine we tie them all up in one box. So this box, AUE, is now just one item. Now what's left? D, G, H, T, R. So we have that one box plus these 5 other letters. That's a total of 6 items to arrange. And how do we arrange 6 items? That's 6 factorial ways. But wait, we're not done. Inside our box, the letters A, U, and E can swap places, right? They can arrange themselves. In how many ways? 3 factorial ways. So now we have 2 things happening. We use our golden rule and multiply them.
And there we go. 6 factorial is 720. And 3 factorial is 6. So our final answer is 720 multiplied by 6, which is 4,320. That's how many ways you can do it. See, when you break it down into simple steps, it's not that hard at all.
So before we finish, here is a little cheat sheet for you. You can take a screenshot of this for your revision. It has everything you need to remember. Permutation is for arrangement, where order matters. And combination is for selection, where order doesn't matter.
I want to leave you with this one last thought, Bacho. The real superpower isn't about memorizing a formula. The key is to read the question and ask yourself that one simple thing. Is this an arrangement or is it a selection? If you can answer that, you've already won half the battle.
And that's it for today. I really hope this made things a lot clearer for you. You are all so smart and you are going to do wonderfully in your exams. You've got this. All the very best. And hey, if you found this helpful, please hit that like button, share it with a friend who might be struggling, and subscribe for more simple explainers. See you in the next one.